Warm-up problems from today. Take a look at them. So we started on the problems dealing with percentages today and had two examples. And the purpose of the two examples were to display the similarity between the percentage notation and the notations that we've already discussed in terms of fractions, decimals, and ratios. And also, the purpose was to show how the percentages give you a method for comparing quantities in two situations where the composition of the items might be different. And so let me explain that one a little more clearly. So here's an example where test had 100 questions and a student got 90 of them correct. Another situation, a similar test, maybe a different class, same test, so to speak. But in that one, the test only had 60 questions and this student got 50 right. So you can immediately see that this person would say, well, I got 90 out of 100 right. And this one would say, I got 50 out of 60 right. But if you're trying to compare them, who did the best? This person would say, I got 90 right. You only got 50 right. However, this one would say, well, I had 60 questions and you had 100. So you had more of an opportunity to get more problems right. So we need to have a way to compare situations where we have different composition mixes, if I could use that word. So pretty clear here that a fraction is 90 out of 100. We're just looking at how many were correct over how many there were in total. Decimal, 90 hundredths, 90 hundredths, divide it out and get 90 hundredths. Ratio, fraction form, we've already looked for fractions. 90 to 100, 90 to 100. Percent notation. This is the new idea. And this little symbol means per 100. Whenever you see numbers with this symbol after it, it simply means I'm giving you an expression of an amount per 100 items. This one's pretty clear. The person got 90 out of 100. There was 100 here. Person got 90 of them right, so it's 90 out of 100, 90%. Now this one, same idea. We can construct the fraction notation, 50 out of 60. Decimal notation, do the division, 50 divided by 60. Ratio, fraction form, 50 to 60, 50 to 60. Now the percentage is a bit of a different calculation. Why? Because we do not have 100 items. So I can't simply say that this is 50 out of 100, it's 50 out of 60. So I have to have a way to convert this relationship to the corresponding number out of 100. The most straightforward way to do that is to take the decimal form. And how do we get the decimal form? We simply said 50 divided by 60. And you're going to get a decimal 0.833 repeating. Now, if you think about rounding that, it would round to 0.83. And say this out loud, you'll get 83 hundredths. So guess what? This is 83%. Now, we're going to talk a little bit about methodology in a moment, but when you have fractions to decimals, decimals to fractions, decimals to percents, percents to decimals, we need to have some methodology for doing those calculations. But you can see right off now we do have a method here. We say, well, this person, 83%, 90%. Even though the base amounts were different, 60 here, 100 here, 90 correct, 50 correct. Now, we will say that this person has a better percentile score, 90% compared to 83%. But now we now have a way to compare these on a consistent basis. So the note at the bottom says, if you're converting from a decimal to a percent, move the decimal 2 places to the right and add the percent sign. So that's what we did. We said, let's move the decimal point 2 places to the right and add a percent sign. Now, if you're questioning yourself about that seems like some sort of magic trick. That seems like some sort of magic trick. So let's just think about just a little bit more. So what I said to you is if I have this decimal value The way I convert it to a percent is I move the decimal point 2 places to the right, and I add the percent sign. How can I justify that? Now, what did we say a minute ago? The definition of percent is it's some number per 100. So this is currently 0.83 over 1. Easy enough. Multiply this times 100, multiply this times 100, and now I get 100 here. And when you multiply 0.83 by 100, you get 83, and suddenly 83 per 100 becomes 83%. You say that was too easy. Well, it is too easy. You simply take a decimal and multiply it by 100 and add percent. That's all there is to it. Take a decimal, multiply it by 100, add percent, and you've got it. If you have the other option, you say, wait a minute now. I've got 83% and I want to go back to a decimal. Well, the mechanics of it are drop percent, move decimal 2 places left. Oh, move it 2 places left. So drop percent, move the decimal 2 places left, and you come back to 0.83. And you say, okay, well now, how is that going to work? How is that going to work? Well, here's how it's going to work. We'll do in reverse what we did up here. So I want to get this to not on the basis of 100. So I simply divide this by 100, divide this by 100. This now becomes 1, and this now becomes 0.83. So there's a calculation reason why it works, but you don't have to think too much. Move decimal 2 places right, add percent. Drop percent, move decimal 2 places left. And so if you can handle adding and removing a percent sign and moving a decimal either left or right, then you've got this. Now, the next problem we had was a situation where we had someone who was going to buy a recliner, and they had 2 options. They could either buy it at one place that was going to reduce it from $250, they were going to reduce it by $20, or the other place said, I'm going to reduce mine by 10%. So you obviously have 2 different ways of calculating what the resulting price is. This one's a little more straightforward. You simply say, well, if it was $250 and they're going to reduce it by $20, then my new price is $230. This one is a little harder because we don't have a dollar amount. We have a percent, and you have to do some calculations. And what would you do? Well, you would simply say, in this case, what I have is I have $250 multiplied times 10% is going to give me the amount of the reduction. Now, one of the things that we need to discuss is that when you multiply or divide percents, you must convert them either to a fraction or a decimal. So this calculation could either be done this way, or it could be done this way. Okay, so either way you do it, you're going to get $25. All right, so I see now. This one is going to be $250 minus $25, so it's going to be slightly cheaper. It's going to be $225. And you say, well, what if I just want to know what the percentage value up here is? The percent, what percent did this $20 represent? You can calculate that using the percent formula. And the percent formula is there is some amount that is a percent of some base amount we refer to. And generally your base amount is going to be, in the case of prices, it's going to be a starting point. In the case of other problems, it's usually going to be the total amount that's involved in the taking of a percent, which is the taking of a part of something. So how would we do this with finding the percent that this represents? We just plug in here. The amount is $20. We don't know the percent, and we started off with a $250 base. And so we did it here. $20 equals a percent, 250. So divide both sides by 250, and you get what? when you do that division, you're going to get an answer over here that says percent equals 0.08. No, that can't be right. We've got to turn this decimal into a percent. Oh, and how do we do that? Move decimal 2 places right and becomes 8%. That ought to make some sense to you. If a 10% reduction does $25, then a $20 reduction ought to be a little less than 10%. And it is, it's a little less. It's about 8%. There's kind of a handy little notational method to remember this percent formula. It's a little triangle here. So if you say, I want to know percent, you cover percent over and you take the amount and divide it by the base. All right. So I wanted to know the percent, so I would take the amount and divide it by the base. In this problem, that's what I did, didn't I? I said, here's the amount, here's the base, took the amount, divided it by the base, and I got a decimal answer, which I had to convert to a percent. What if I needed to know the amount? Oh, that's what we did a minute ago, where we took the 10%, the 10% times the 250 gave me $25 as the amount of the reduction here. So if you want to know the amount, you cover up the, can't see that, can you? If you want to know amount, you just cover it up and multiply percent times the base. If you want to know the base, you cover it up, divide amount by percent. Now remember, you've got to convert these percents to decimals to do this calculation. So one more time, if I want to know the percent, amount divided by base. I want to know base, amount divided by percent. I want to know amount, percent times base. So if you'll do a few of these problems, this will fall into place for you. Now, the one thing that we didn't discuss today that we'll pick up the next time is the other method, which is called the proportion method. And if you will think about the work we did with ratio and proportions, it'll be very clear to you how that's going to work. So at any rate, we'll pick up and do calculations using proportions next time. So percent calculations are everywhere. On the news, they talk about inflation is at 5%. Businesses reduce their prices by a certain percent. Or we say prices have increased by a certain percent. Sales tax is usually a percent of the value of the item that you're buying. So percentages are everywhere. And I hope these simple examples help you out here.